All right, class. Welcome to part two of the 5.1e lesson on scientific notation. Um, let's just get right to it. Number 4 says in July 2017, Facebook was worth, whoa, so that's 500 billion? Is that accurate? Anyone know how much Facebook is worth now? Write this number in scientific notation. Okay, so again, we have to move the placeholder to the first significant figure. The most significant number is obviously that 5. So we're going to move from here 3 units, 6 units, 9 units, a total of 11 units backwards. So, and you basically move it to 5, and you can write 5.0 if you want, or you could just write 5, but it's 5 times 10 to the 11th power. Wow, that is a very large number, right? Number 5, the diameter of a human hair is 0.0000099 meters wide. Write this number in scientific notation. So I'm just going to go 1, 2, 3, 4, 5 placeholders forward, and I become a 9.9. And the 9.9 is really happy, but the reality is you have to take away those 5 placeholders that you just gave it right back. That's how you convert from a standard form number to scientific notation. Okay. Number 6, explain in words why the number 27.5 times 10 to the negative 3 is not written in scientific notation. Okay, so what do we think, class? Why is this number not written in scientific notation? Well, it's because that decimal is not in front of the first significant figure, right? So the decimal should be to the right of the 2, not the 7, right? The 7 is not the most significant number. The most significant number is the 2. So I have to move it one more placeholder to the left. I'm taking one more away. And if you take away, you cancel it by adding 1 to the power, right? Think about it, class. Taking away is like saying 10 to the negative 1. And then adding 1 more power to the here is like saying 10 to the 1, right? And we all know that 10 to the negative 1 times 10 to the 1 is going to result in doing nothing. This results in just canceling itself out. Nothing has changed. So if you take away a placeholder here, you better provide a placeholder back to the exponent, right? So the number written correctly would be 2.75 times 10 to the negative 2. Okay, examine the numbers below. If the number is written in scientific notation, circle it. If it is not written in scientific notation, rewrite it. Okay, so let's first scan. Is anything written in scientific notation? I think C is and E is. Okay, and then what I want you to do now is I want you to practice on this section and convert. These are almost in scientific notation, but you're going to have to switch them. So let's just go randomly. Let's go with letter A. I'm going to take the decimal and move 2 placeholders backwards, minus 2. So then I add 2 to the exponent, right? Again, this movement and this movement will cancel. So I get 3.48 times 10 to the 10th power. Okay. Show your work by showing you're moving how many places, you're adding how many places. They always have to cancel. Here I'm going 1, 2, 3 units forward, so plus 3. And then here I need to take away 3, right? It's just if you go forward, you have to go backwards in your exponent. So you get 4.026 times 10 to the 6th. And you realize this number right here is going to give you the same exact number that you would have gotten on the original problem, right? Move 1 placeholder backwards, add one placeholder to your exponent. 4.55 times 10 to the negative 5. And then finally, 1, 2, 3 placeholders forward, negative 3 placeholders backwards, 7.42 times 10 to the negative 6. Okay, you gotta think about that, right? Show your work using this display. Positive 3 movement, negative 3 movement, negative 1 movement, positive 1 movement, positive 3 movement, negative 3 movement. All you're doing is you're switching the alignment of the decimal. All right, last question. Tiffany explains to Jennifer that the scientific value of 6 times 10 to the negative 5 is larger than the value of 3 times 10 to the negative 2 because 6 is larger than 2. Wow, that is interesting. Jennifer disagrees with Tiffany and believes that 3 times 10 to the negative 2 is the greater value. Who is correct? Okay, so this is a misconception for sure by Tiffany, right? Do you think just because the first number 6 is greater than the second number, the second term's first number 3, just because 6 is greater than 3 does not mean that this number is immediately larger than that number, right? More importantly, in scientific notation, you obviously have to look at how many placeholders you're going to go either backwards or forward. In this case, 6 times 10 to the negative 5 is telling you to go 5 units backwards, and you can you realize that that's going to give you 4 zeros and then a 6, and that's small. That's really, really small, right? And then 3 times 10 to the negative 2, you're only going 2 placeholders backwards, so that's 0.03, right? So Jennifer is definitely correct. You must look at the degree of your 10 to really determine which one is bigger. Now, if they had the same exact exponent of negative 5 and negative 5, then Tiffany's logic would be correct. So Jennifer is correct because overall value is because the overall value is determined by the power of R10, right? So this is telling you to go 5 units backwards. This is only telling you to go 2 units backwards, right? Again, let's do another quick example of that, right? Let's say we're talking about money here, and I had $8 times 10 to the 6th, and you had $9 times 10 to the squared, right? Like, which one would you rather have, 9 times 10 squared or 8 times 10 to the 6th? You obviously know that this is going to be a huge determining factor of how large your actual number is. Even though 9 is greater than 8, it doesn't matter what, I mean, this first number does matter to some extent, but it only matters if you have the same exact power. Okay, I hope this example made sense, and I hope this page was easy. Thanks for watching. We have one more page to go, but I think we should definitely do that as a class. Okay, thanks for watching.